In geology, the word mineral has a definite definition. It's got to be naturally occurring, it needs to be a solid, it's formed geologically, not man-made, it's crystalline in structure, it has a definite chemical composition, it can vary a little bit, but it's set, and it's mostly inorganic. So let's go through each of the parts of that definition and clarify. What is a mineral? So they're naturally occurring. It is truly made by a natural process. We can make a lot of minerals in a lab. If we make it, humans make it, we're going to call it a synthetic mineral, not a mineral. It's a solid. So look at these images here. A solid doesn't fill up its volume of space. It keeps its shape. It's a state of matter that can maintain its shape indefinitely. It's not going to flatten out in the jar or a gas that fills up the volume of a jar. So it's solid, not a liquid, not a gas. So we like to use the example that ice is a mineral, naturally occurring ice, but water is not. Formed by geological processes. So the solidification of a mineral from a melt, like a magma, it can precipitate out of fluids. There are chemical reactions with high pressures and high temperatures. So all of that is going to give us different kinds of minerals. Living organisms can create minerals. See the inside of this shell here. That's aragonite. So if a organism creates a mineral, we're going to call it biogenic mineral. So a biogenic mineral means that it is technically a mineral, but it was made by an animal, kind of like a synthetic mineral is made by humans. So a lot of examples: our bones, vertebrate bones, oysters, mussels, clamshells, other skeletal types. A crystalline structure. That means that the interior of a mineral is organized. The atoms are in a set atomic array, and for every mineral, it is defined and set. And if you change that crystal lattice, that array, that order of the atoms, it becomes a different mineral. If you take those same components, all these little green balls, and you mix them up, and they're not in a lattice, they're not organized, we call that a glass. So glasses are not necessarily minerals because they don't have that crystalline structure. You have to be a crystal to be a mineral. Okay, the set chemical composition. So here are a couple of the simple minerals with a simple chemical composition, like halite, NaCl, and here's the model of it with the balls and the sticks and balls. You have sodium and chlorine organized in that atomic array. So if you change the sodium or the chlorine, it's no longer halite. The same thing with calcite, CaCO3. Any of that changes, it's no longer calcite. Quartz, SiO2, silicon, and oxygen. There are some more complex chemical formulas like biotite and hornblende and many, many others. So for biotite and hornblende, see in parentheses, there's Mg, Fe. That means at that particular spot in the atomic array, the crystalline lattice, it can either be magnesium or iron because they're similar sizes. The atomic radius is similar, so that those two elements can sub in for each other. And in hornblende, there's the OH and the F, and they can swap out for each other within that crystal lattice. So that there's a set chemical composition, but there can be variability within one place, one or two places in that lattice. Inorganic. Okay, so the mineral needs to be inorganic. There are organic compounds that can contain carbon-hydrogen bonds and other elements like oxygen, nitrogen, sulfur. Those are all going to be produced by living organisms, and those are not minerals. All right, so what is a crystal? A crystal is a single continuous piece of crystalline solid. So that, look at the images here. that blue crystal has the same atomic array throughout the whole length of it. It's not going to change. If it changes, it becomes a different mineral. The boundaries of a crystal are going to be flat surfaces. We call these crystal faces. Some people think that crystals are powerful. We can get special powers from them, but science has revealed that they really don't affect your health or your mood. Kind of like a placebo, right? So remember back to Steno, he was looking at the geometry of the minerals and came up with these measurements of the interfacial angles. That means between two faces, interfacial angles, you're going to find the same angle between the faces on every crystal of a particular mineral. And that's because the crystal faces and the geometry of those is based back on that crystal lattice, how the atoms all fit together, give us the shape of the mineral. And since that's always the same, then the crystal is always going to be the same. So here's some examples of different crystal shapes. Halites are going to make, let me turn my face off here. Halite is going to make a cube, a diamond, like a double pyramid. Starlights make these funky prisms that can be twinned, and they can make a T out of them. Quartz has that typical shape where it's a long prism with a point on the end. Garnets are dodecahedrons, like a round crystal with a bunch of different sides. Stibnite would look similar to quartz, but it doesn't have that same shape on the end, the pointy kind of pyramid as a quartz does. Calcite is kind of a skewed rhomb, and kyanite are these blades of blue crystals. So crystals can look very different from each other.